Hello and welcome to the second part of naming binary compounds. Now today we're still on binary ionic compounds and we're going to add one of our rules back in. We're going to add in and do some polyatomic ions. Now I have our overall rules here. We have seen this before when we first started naming binary ionic compounds. We name our cation first, which is the positively charged ion. And we name our anion second, which is the negatively charged ion. Now in this case, when we're naming our cation, we have two options. We can have a single element, or we can have a polyatomic ion. Now when we have a single element, like here, or even with this rule, those are called monoatomic ions. That mono meaning one, so one type of atom. Polyatomic means multiple atoms in the ion. And we'll see a couple of these in the table. I'll show a table full of polyatomic ions. But what those are different atoms bound together, and they are like a unit. They're a unit together, and that is the ion. Now, we still haven't gotten to this last rule yet, so I'm going to cross it out. We still aren't to this rule yet, but we are going to be adding in these rules. Now here is my table of polyatomic ions. We see a wide range of different elements here. We see some nitrogen, hydrogen, oxygen, sulfur, and so forth. Now let's look at a couple in depth. Our first one here says NH4, and then there's a plus. This is a cation that's a polyatomic ion, and its name's ammonium. Now ammonium is made up of one nitrogen and four hydrogens bound to that nitrogen, and overall this unit has a positive charge. We can think of these like building blocks. We can add these as ions just like we would, for example, a chloride ion, but instead these are a whole unit together. So nitrite is a nitrogen with two oxygens bound to it, and overall this entire ion has a charge of -1. Now some of these have a variety of charges. We see sulfite and sulfate have -2 charges. Phosphate has -3, and we see some different charges over here. Now for the naming of these, all we need to do is write the name when we identify that we have one. We don't need to change the ending like we do with the monoatomic anions. In this case, we just write the name. So if we see NO2, that's just nitrite. If we were to see ClO3, that would be chlorate. Now what I have here is a couple of practice problems. We're going to use what we see here and apply our rules to them. Now of course we still aren't using these rules yet. That will be in part 3. We see MgCO3. Now one of the tricky things with these is to identify what your polyatomic ion is. In this case we know that Mg, because it's a capital letter and a lowercase letter, we know Mg must be an atom. It must be one element. In that case, it is magnesium. For this, all we need to do is write the element name. That's our cation, and so we would write magnesium. Now, the rest of this is CO3. Now, let's go to our polyatomic table and see what our polyatomic ion name is, because we don't need to do that root plus ID. We come over here to this rule. Now CO3 is right here, and it says its name is carbonate. All we need to do here is write carbonate. So these are two words. Our first word is magnesium, that's our cation. Our second word is carbonate. Our overall name for this is magnesium carbonate. Now let's try another one. I have Sr, and then in parentheses, NO3, and then a 2. Now, polyatomic ions, I described them as being a unit or a building block. We can't just put a 2 right next to this oxygen 3. The reason for this is because we need two whole sets of NO3 if we want to change how many we're talking about. So we can't just put a 2, in front of the N and then turn this O into a 6. We can't do that. We need to put parentheses around these because NO3 is a unit altogether. We want two of those units. And we're going to come over here. This NO3 is nitrate, and it has a -1 charge. We see that minus right here. Now the reason why we need 2 of these nitrates is because strontium is right here. Now strontium's in the second column. In the second column, these are all +2. So if strontium's +2, in order to be a neutral compound, there needs to be 2 nitrates. Each one of these nitrates has a -1 charge. So we can kind of think about it as strontium has a +2, and each nitrate, well, one nitrate would just be a -1, there would still be this positive charge here. We need that second minus charge to cancel out the charges. Now let's name this. This will matter a lot more when we're going back the other way, but let's name this one. Now I've already given away the name for Sr. We're going to do the element name. This one is strontium. Now for our polyatomic ion, we're pretty set. We just need to go over here, find the name. In this case, I already did point it out. It is nitrate. So in this case, we can have multiple polyatomic ions. In this case, we do have to put a parenthesis around them and then put our subscript out here. So we could have 2, we could have 3, we could have 4. We just need to make sure we put that parenthesis and the subscript on the outside. Now we see this again. We see another polyatomic ion in parentheses, and this one says C2H3O2. Now let's go find this polyatomic ion. This polyatomic ion is right here, and its name is acetate. So let's figure out the name for this compound. We see Ca here, and Ca is right here on the periodic table. This one is calcium. And then we have C2H3O2. Now we just figured out that name's acetate. It doesn't matter how many there are. All we need to do is do that polyatomic ion name. So in this case, we've done our element name already. Now we just need our polyatomic ion name. This is calcium acetate. And that's the name for this compound. We're going to do one last one. We have K2SO4. Now in this case, we had actually seen where we had multiple polyatomic ions. In this case, we actually have multiple of our monatomic ion. We have multiple potassium cations right here. We have 2 of them. So this 2, remember that goes to the thing that's directly before it. So this 2 goes to the potassium. In this case, there's only one SO4. Now let's figure out the name for this. The first thing we need to do is, because we see it's a K, we need to figure out the element name. K is right here. It's potassium. We have potassium here. Now SO4. Let's go find this on our table. SO4 is right here. Now SO4 is 2-. That's actually why we needed 2 potassiums. Each potassium is +1. So in order to have it be a neutral compound where SO4 has 2 negative charges, we need 2 potassiums, each with a positive charge. Now the name for this is potassium, and let's add our polyatomic ion name. This is potassium sulfate. Now we'll continue to do some naming in this series. Our next bit of naming will be this last rule where we have the Roman numerals in parentheses. So our next video in part 3 is going to be about this. And then as we go through the rest of these parts, we'll start talking about some covalent molecular compounds and some overall general naming rules. So I hope you enjoyed this video, and if you have any questions about this, you can let me know.